Up next, I want to bring on our next three panelists. We're going to talk about interoperability and how multi-chain universes are about to overlap. So please join me in welcoming Dominic from DFINITY, Tiancheng from Polyhedra, and Brandon from ZetaChain. We're seeing a lot of chains come up. We're seeing a lot of specializations, application-specific items. And this kind of leads us to being in a more interoperable and multi-chain-centric world. So the focus here is to learn about sort of how we can think about solving these problems and not put that burden on the user. And I want to kind of start off with you, Dominic. Just wanted to understand if you can give us an update on how the DFINITY and the ICP ecosystem is going. What have kind of been things that you've been working on towards this goal, and we'll kind of start off with some general updates there.
It's going well. The big development in the community is the formation of something called ICP hubs over the last 6 months. And there are about 20 of them around the world now. And some of them are growing quite big. The Indian ICP hub, I think it's about 10,000 developers in a hackathon funnel right now. We had a meetup in Korea with 800 people. And these hubs are fundamentally independent. So it's a kind of build locally, scale globally paradigm. So that's going very well. Internet computer still chugging along. Currently processes about 200,000 ETH equivalent transactions a second when you're looking at the actual number of virtual machine instructions being processed. So it's, I think, the highest throughput chain in the world right now. And yeah.
Awesome. I want to start off with you, Brandon. Could you give us an overview on what you've been working on and sort of why you decided to focus on this as a problem?
Yeah, so hi, I'm Brandon. From ZetaChain, and ZetaChain's a new L1 focused on interoperability first. What that means is you can deploy a smart contract on ZetaChain, and that smart contract has access to an interoperability layer to virtually any chain. So you can read and write from Bitcoin in the same way you would read and write from Ethereum or any other chain. That lets developers build cross-chain apps very easily. You can, deploy a Uniswap and it becomes a cross-chain app in a few lines of code, not, a few months of development.
Awesome. And finally to Tiancheng, tell us about what you've been working on and why you decided to focus on it as well.
So I was working on actually zero-knowledge proof during my PhD area. So after 2021, and after the end of 2021, there have been many breach attacks happening and lost billions of dollars. So at that moment, we kind of thinking about this problem, and we think we can use zero-knowledge proof to solve this problem. We invented a protocol called ZK bridge, and then later on published papers and start this project. So we submitted a paper at May of 2022, and the project immediately started at, I think it's October or November. And so the ZK bridge basically uses a proof to prove the validity of the block header and the messages. So your transaction message, or your cross-chain message is not secured by any kind of committee or intermediate layer, but immediately secured by the zero-knowledge proof. So it's kind of, we removed every vulnerability, every security assumption, and trying to minimize the attack surface only to the circuit itself. So yeah, and yeah.
Sorry, does that approach also prevent double spend? Because that's just proving the asset is correct on the communication side, but
yeah, it prevents double spending because it basically proves that the transaction has been successfully included by the sender chain. So there is no way to double spend it as long as the sender chain don't fork.
Understood. Okay, I misunderstood where the proof was. It's not on the communication side. It's on the chain. Got it.
Yeah, on the chain side actually.
Interesting. So, Dominic, I think you also have an interesting take on bridges. how do you think about the need for bridges to do cross-chain transactions?
I mean, I've been in crypto for a while. You know, I transitioned to full-time work in crypto in 2013. You know, back in the day, you know, people were much more focused on the math and the security proofs and so on. And generally speaking, I think that blockchain is about, you know, provably secure protocols. And the moment we start processing assets that are wrapped and held in bridges, which don't provide the same security properties, we undermine the benefits of blockchain. And, you know, we've seen a lot of hacks at bridges in the last few years. I forget what the number is. It's
in the billions.
It's in the billions, yeah. I think it certainly exceeds 2 billion. It's probably up at 3 billion or something like that now. So, you know, the internet computer takes a different approach. It supports something called chain key cryptography. And this enables the internet computer to create transactions on other blockchains. So this far, the network's been integrated with Bitcoin and supports something called chain key Bitcoin, which is like a Bitcoin twin, a trustless Bitcoin twin with 1 second finality. You can use it in DeFi, SocialFi, whatever you like. And currently, the DFINITY Foundation, we're working on ETH integration. But parts of this already work. So, for example, there's something called the Oisy wallet. It's a walletless Ethereum wallet. It's in a web browser. And, you know, what's happening is you're authenticating yourself in a crypto session to ICP smart contract. And that ICP smart contract creates an EA account for you. And there's no private key, but it can sign Ethereum transactions. So, you know, you can open Oisy Wallet in a web page, and now you can use Wallet Connect to link that to Uniswap in another web page, and, you know, essentially conduct Ethereum transactions without an Ethereum wallet. So that gives you an idea of the kind of capabilities, but that same functionality can be used to link different blockchains. So in principle, using chain key, it would be possible for example, a smart contract on Ethereum to call directly into a smart contract on Solana. So it's not even just about moving tokens, and there's no intermediary. You can actually get the network's nodes talking directly to each other, or alternatively use your user experience to move transactions across. But there's no trusted intermediary. It's relying entirely on cryptography and provable math.
In that first example of the wallet that you talked about, does somebody still need to execute that transaction to broadcast it, and somebody takes on that risk of maybe never broadcasting it to Ethereum? Or?
Yeah, so that's where the complexity lies with the internet computer Ethereum integration. But with the Bitcoin integration, internet computer nodes talk to Bitcoin nodes, and there's a certain level of redundancy, and if the transaction is not seen, then some nodes will resend the transaction and things like that. So it's taking that responsibility away from the developer or the user.
Interestingly, Brandon, you're also doing multi-chain Bitcoin through ZetaChain. Could you tell us about how that works, what's kind of happened so far, and sort of specifically what it enables compared to other kind of bridges we've seen for Bitcoin?
Yeah, so I think pretty aligned with ICP, and we're trying to minimize new wrapped assets. So in an ideal world, even if you are transacting across many different chains, you start with a native asset, or like you're on Bitcoin and you settle also on another native asset. You're not creating a new wrapped asset every time you're making a new chain pair. Specifically for Bitcoin, it's kind of a trope now that a lot of people say, all of this liquidity, all of these users are on Bitcoin network, grandma and grandpa. They have Bitcoin in a wallet somewhere, but have no idea how to use it. In many ways, because there's no actual route to use it unless you're bridging it to Ethereum or some other blockchain. So for us, we're very focused both on developer experience and user experience, where, again, for this Bitcoin example, you never have to leave Bitcoin network or leave your Bitcoin wallet to call a contract that interacts with many different chains. So you can just send a transaction, just an OP return or memo on that transaction, and that can specify what contract you're going to call, metadata, whatever. So everything you're doing in this space with ZetaChain is one step. You're never having to really change network unless, there are use cases where you need to or may want to, but if you want to just stay in your like safe Ledger Bitcoin wallet, you can do that and also settle natively. That is all done, I think, in a similar architecture to chain key Bitcoin. From my understanding, probably some nuances, but yeah, that's kind of where we're at.
Awesome. And then kind of maybe, so I want to zoom back a little bit and just actually talk about what the problems are before we kind of go into how we're solving them. So Tiancheng, my question for you is, could you give us like a slightly more detailed version of what the problems are with bridges right now? We kind of just hear about they got hacked, but let's understand why, the common reasons these things happen. But yeah, so it'd be great to just kind of get that context, and or can I answer that from the bridging side? But then I'd like Brandon and Dominic to comment on the cross-chain communication piece on some of these vulnerabilities.
So you are asking the data hacks, right?
Just generally, what are security considerations or common things that go wrong with bridges?
Okay, previous bridges, like most hacks happens on the smart contract level, where you...
Is it specifically the bridge contract
Yes.
interfacing with a different chain?
Yes.
Okay.
The bridge contract and some of the application contracts. So in our side, the bridge contract is just a zero proof verifier. It doesn't do anything except for the verification. So we basically moved the vulnerability from the contract side to the off-chain circuit side. And secondly, we are more focused on the connectivity. So we don't actually do asset transfer or NFT transfer. We only do is data transfer, where you transfer bytes between different chains. So it's basically decouples the application layer and the transport layer. So for our company, we are kind of more focused on the transport layer implementation. So this can be things can be more simplified for our side, and we also do some asset transfer or NFT bridges as a demo or demonstration application. So that part can be further dedicated to more specialized team in the field. Yeah. So kind of we are trying to minimize the attack surface. Second, we trying to decouple the work into different specialized teams. Yeah, so make sure just make sure smart contract hacks don't happen.
Yeah.
Again. Yeah.
Even in the case of kind of getting rid of bridges, do we still have the smart contract on the integration side kind of being potentially vulnerable? Like, how do you kind of, in a way, minimize that risk of the contract that is in charge of communicating what that state change would be on the other side?
Well, there's sort of two different levels to think about the issue with bridges. The first is you've got three parties. So, for example, if you had a canister smart contract on the internet computer, and it wants to instruct an Ethereum smart contract, there are two blockchains involved. Ideally, you wouldn't introduce a third party, the bridge in the middle, because the more parties that you have, the higher risk something goes wrong, right? That's the first problem. The second problem is that, a bridge isn't a blockchain. So it has completely different properties. Many of the bigger bridges are just like a handful of nodes run by a bunch of insiders. No one even knows what source code runs on them. Essentially, they're wrapping tokens. So we saw this, with the with Wormhole ETH, for example. I think the Avalanche bridge has 5 nodes and no one's seen the source code. So essentially, when you're using that bridge, you're entrusting your crypto to whoever's running. And, bridging is a pretty diverse field, and some bridges are more secure than others, and some are more centralized than others, and so on and so forth. But there are two levels of problems. There should just be two parties, like it's one blockchain talking to another blockchain. Why do you need a third party in the middle? And we know from, Satoshi back in the day that the whole purpose of a blockchain is to remove intermediaries. A bridge is an intermediary, so we shouldn't want the bridge. But it's actually worse than just introducing an unnecessary intermediary. That these bridges on blockchains, they're insecure and you have to trust people. And the whole point about blockchain is that you don't have to trust people. So they're bad things. So on the internet computer, you have a smart contract, and it can create for example, an EA account. It's just a key pair. But although there's a public key created that the smart contract can manage, it doesn't have the private key. And in fact, there isn't a private key. The chain has to sign for that public key itself using this chain key arrangement. And, obviously threshold cryptography is involved, but that's a gross oversimplification. There's actually a lot of things you have to do to make these chain key cryptography frameworks work. But essentially, a smart contract on the internet computer can create transactions on Ethereum, Solana, Avalanche, whatever it needs to. Currently, we've kind of completed the integration pretty much with Bitcoin. Ethereum works ongoing, albeit you can already do amazing things like I've been showing people here, the Oizy wallet, which is just a web page, it's an Ethereum wallet that integrates with all of the existing Ethereum DeFi. And I'm sure all of you have used MetaMask on your phone, right? You open the MetaMask wallet, takes 30 seconds to open or something, and then you have to press the web browser and you get a sub-web browser inside the MetaMask application. It's completely game
Not as easy as it could be.
Yeah, the experience is game-changing because now you just have this page and there are your assets, and from that page you can send assets, and you can link it to any Ethereum DeFi service you like, and there's no app. There's nothing that can be blocked. There's no centralization. It's all gone. So that's working. And but what's coming next is the network level integration. So internet computer nodes will talk to Ethereum nodes in the same way that they talk to, well, they already do, but in the same way they talk to Bitcoin nodes. And there'll be APIs within the canister smart contracts that allow you to do this kind of thing.
Awesome. And by the way, please feel free to add on anything. This is not meant to be a one-by-one type of thing. I think the thing that is super interesting to me is that effectively every time somebody talks about bridging and cross-chain communication, they're kind of largely stuck at, let's just transfer assets from one place to another. And granted, that's a super majority of those use cases. It's not really kind of how the space is moving forward, which is we're getting a lot more application-specific use cases, destinations. People are focused on, hey, if you have a heavy compute workload, go here. If you have this specific circuit requirement, go here. And that to me is like the core use case for multi-chain worlds. My kind of question is, in that world, how do you think about kind of separation of compute versus assets? And largely, is that the same to the service? Like, are we just still passing bytes and it doesn't matter? Or is there something better or something that we need to add or improve to what we have right now?
ERC20 is implemented with a smart contract, right? So, why not generalize it and allow smart contracts to talk to smart contracts? And, different chains provide different properties. They're specialized for different purposes and so on. Ethereum has an architecture which makes DeFi very straightforward because you just have a single public key and that holds your balances. And, you'd be in one app, and you can see your assets. You can go to another app and you also see your same balances. And it's a synchronous, one transaction at a time architecture. Internet computer is a very different kind of architecture. Smart contracts are software actors. They run in parallel. A single smart contract can have 96 gigabytes of persistent memory pages inside, along with the WebAssembly bytecode. Internet computer smart contracts can process HTTP and deliver user experiences directly into browsers and things like that. So, the integration at the smart contract level will allow Ethereum dApps to leverage all of those kind of things that you get on the internet computer. So smart contracts can all of a sudden store and process gigabytes of data if that's what they want to do. All of a sudden, smart contracts can directly serve dynamic, interactive user experiences directly into browsers, and that's it. Oh, and coming soon on the internet computer, AI. There's already large language models running as smart contracts on the internet computer. So,
that's going to be an interesting world.
Yeah. So, with smart contract level integration, all kinds of really cool things become possible. So I think, even, people talk about tokens, it's easy to do. But look, ERC20 is a smart contract already. Of course, we should generalize it, and it should be, we should have all of these chains be able to host smart contracts that can call into each other.
Brandon, do you have any kind of comments on how you're thinking about?
Yeah, so I agree with a lot of what Dominic said, where, like, to your question of, do we just need asset transfer or do we need something more? I think with current, kind of like the zeitgeist of interoperability that is like a couple years in and being adopted now is this cross-chain messaging piece where you're essentially, you're passing bytes to another chain in simple terms. That's sort of like, I would call it asynchronous, where you have one contract that calls to another. If you're managing across 10 chains and you need a synchronized state, you have to broadcast a bunch of messages and do that whole thing. It gets very complex. If you have something that is more synchronous, where you have a programmability layer, you can orchestrate not only assets but data. So if you have an on-chain game or social network or whatever that is, you can take the best parts of a high compute chain, do whatever compute you need to do there, or data storage, and then you also have access in the same app or in the same logic piece to bring Bitcoin liquidity in or bring value in, where kind of like meeting users where they're at. So I think there's a space for both sides, definitely.
I just have a few questions for DFINITY. Yeah, so I'm not familiar with the internet computer. Is it just a consensus among a lot of committee members?
Well, so it's a big question, but internet computers, runs on dedicated hardware. So you have people called node providers that run things called node machines, and so it's more similar to Bitcoin in that sense. It runs on sovereign hardware, not on cloud, and the network has a governance system, and it organizes these node machines into subnets. And because of the way chain key cryptography works, it can combine these subnets into a single smart contract environment. So there's no partitions, there's no real concept of like a parachain or something like that. Every smart contract can directly call into every other smart contract, but it's an asynchronous environment in the sense that these contracts are running in parallel. The actors at the lower level, this deterministic message passing, but the messages, of course, are smart contract implications and smart contract results, if that makes sense.
Yeah. I don't have further comment.
Maybe for all three of you, how important is EVM compatibility in this world? And is that in a way essential? Does that mean it could just be componentized and modularized so that you can swap it with any VM? What's kind of the general thinking around just EVM as a runtime there?
Well, it depends what your application is, right? So, look, I was, I've been working on blockchain theory for a very long time, and I was involved with Ethereum early on, and got enamored with this idea of a world computer. But my interpretation of the world computer vision is that eventually there'll be a sort of blockchain singularity in the sense that, most back-end systems and services, will run on blockchain. And if you want to get there, then you need a different kind of VM that's more performant. You need to be able to run smart contracts in parallel. And, in the case of the internet computer, rather than like a Patricia state tree, you have persistent memory pages that, WASM bytecode that you've created with Rust, Motoko, TypeScript runs within, and it's very, very efficient. And actually earlier was, I think you said he was 8,000 times more efficient than Ethereum.
Cheaper, but for call data.
Yeah, so I think the internet computer is 1 million times more efficient. It uses something called deterministic decentralization to reduce replication by looking at the node providers, the data centers, the geographies of the data centers, the jurisdictions of the data centers, all kinds of stuff. And, it's conceived as a smart contract cloud upon which you can really build anything. But, if you're looking at DeFi, there are huge advantages to having a much simpler model where, you have one account and all of your balances are associated with that. And it sort of follows you as you go between different DeFi apps. Similarly, synchronous calls very simplify certain aspects of DeFi. So internet computer smart contracts run in parallel. Actually, it's a privacy preserving system. So you certainly don't have one private key. Every
Right.
in smart contracts is a different pseudonym. So I think that horses for courses, right? But however, there's a project called DFINITY, and they've implemented an EVM on the internet computer. And
Is that just a runtime as a contract, or is it a bridge? What exactly is it?
yeah, so each internet computer smart contract can have up to 96 gigabytes of memory pages. So you can fit a lot of EVM state trees inside. So that obviously doesn't scale out though, because you can only have one hardware thread inside a ICP smart contract at a time. So what you can do is you can create different EVMs on different subnets. That's what's happening behind the scenes. It's transparent to the contracts themselves. And I know I think there's been quite a bit of interest in it. And one of the advantages is you can, for example, use Chain Bitcoin and things like that. So all of this will work seamlessly. So that's not that's not the internet computer per se. That's a project that's being built on top of the internet computer. And I think it's going to be exciting to see how that works, especially with the Ethereum integration. See what happens.
And for you, I think you're also leveraging Cosmos SDK, so that already required a second level of kind of extra work to make it EVM compatible. Could you talk us about that process and sort of the decision framework there?
Yeah. So it was a very active decision, Cosmos EVM. And as I mentioned before, like one of our guiding principles is just improving the experience for users and developers, and going EVM compatible, at least for our V1, is just a way to make it very easy and low barrier to entry for the existing developer community. So the majority of smart contract developers are experienced in Solidity building on EVM. We let you basically bring any app you have on an existing EVM and deploy that and bring it across chain.
But does that mean that's the final decision you've made, or you can support any other runtime in the future because it's designed to be that modular?
Yeah, so it's designed to be modular. I would say probably not in the near term we would go to Cosmosm or some other VM. But the way it works is the interoperability layer is kind of like a threshold signature scheme. Validators can read and write from other chains. Smart contracts on our EVM have access to that read and write. So in the same way, you could add in a Cosmosm runtime where those contracts can also read and write in the same way. But as I said, for now, we think EVM is sufficient or more than sufficient to achieve a lot of the things that developers want to achieve. It's not necessarily just bringing Compound off a Uniswap onto ZetaChain, but also building with this new mechanism, a Bitcoin-backed stable coin, that sort of thing that just isn't really possible right now, but is something that people understand how to build in EVM land.
So our technology actually don't care whether it's a EVM or not, or whether you are at layer 2 or not. We only care about the consensus algorithm itself, and can we implement the consensus algorithm in the zero proof. So that's all we care about. So we kind of compatible with all kind of chains, of course, except for Solana. Their consensus rely on verifiable delay function where too many hashes for us needed to compute the consensus. Only this exception, other chains we seems working on very well. Yeah.
I mean, one thing that I'm noticing here is that we're all kind of trying a small tweak to the things that, in a way, a couple of you are already doing. Obviously, not all three of you are doing the same thing in terms of just solving cross-chain communication. What are kind of your opinions on standardization? And does that mean we got to just potentially agree on something to not repeat the things, or is just my way better until it works and hope that others adopt it, at least for the sake of people's money? What perspective should we have on standardization for these types of things?
I mean, it's a good question. Look, I think, things kind of get standardized all on their own. I mean, like EVM's a huge standard, right? I don't know how many EVM implementations there are today. It seems to be a new one popping up daily. Look, what's the most fundamental standard in crypto, would you say, today?
ERC-20.
No. Something more basic.
Hash.
ECDSA, right?
Okay, I see. Okay,
ECDSA,
sure, yeah.
Think about it.
Yeah.
I mean, that's probably the...
Just public-private key
Yeah.
generation. It's very...
You have an ECDSA pair, and you can keep Bitcoin, Ether, whatever. So, that's a standard. Chain key cryptography supports ECDSA. Smart contracts can create ECDSA signatures without having private keys in their possession. So that means, if you have a chain that supports chain key, you can now create transactions on any other blockchain. So I guess, that's an example of, if you go down the stack and you look at the...
You'll see something that's common.
Yeah, the most basic thing, the foundational standard that we all use is, the signature schemes that authenticate transactions. So, if you support doing that in a multi-chain way, you can integrate anything, and then that allows people room to innovate on the higher layers. So, if an internet computer smart contract, an ICP smart contract, wants to create a transaction on Ethereum, it doesn't matter what the format of the transaction is. All it's got to do is sign a message, right? Same for Solana, same for Avalanche, and so on. So I think sometimes it's important to, think about what level standards exist. And the danger is if we create standards too high in the stack, when something changes lower in the stack, then it'll kind of goes to hell anyway. But the other one, by the way, is HTTP. That's another really fundamental standard. So that's Internet Computer Smart Contracts process HTTP. But we do actually look. I mean, the Internet Computer has you've got Internet Identity. It's a crypto session-based model rather than a wallet-based model. So front ends are creating lots of transactions transparently in these crypto sessions. And we're adding properties to Internet Identity, but we're using the Web3 Consortium credential standard. So we do, which
is great. Yeah.
Yeah. I think so. Standards are very important, but sometimes we miss that it's really fundamental things that unite us, and the most fundamental thing probably in crypto is just the public key schemes.
Fair enough.
Well, you are talking about standardization, of bridges. So what do bridges do actually? Think about this. It's doing transmission of data between blockchains. So think about this. Standardization of data transmission is actually has been standardized before, right? There is a TCP/IP protocol where it handles every single internet data transmission, but the underlying hardware can be different. So I think in the human history, same standardization process has happened, and we can basically follow that route. We can have a standardized format of data transfer, but the application on top of it, like asset transfer or NFT transfer, can be diverse. Yeah.
Yeah, I think I like to use the analogy of countries a lot, where it may apply to blockchains more directly, where you like there has been a lot of consolidation of countries or reconsolidation of countries over time. There are larger players, Ethereum, Bitcoin, but is a space for more specialized chains, whether it's like something DA focused or storage, compute. And I think the same goes for these interop solutions. There is, the parallel of TCP/IP, where there is some way of communicating that everyone has kind of agreed on because it now is standardized. And I might equate that to something like boats for like freight transfer. I think there are a lot of flavors of boats in the same way there could be a space for many different types of messaging protocols. But I think there's also some standardization in the more like global way of doing things, something like SWIFT, how like countries would do cross-border payments through one single sort of agreed upon system. I think there's probably a space for a few of those as the great space grows, and kind of what I imagine the standard being is not necessarily a protocol, but more like an application or like a specific system that has been built to do things. So SWIFT is an example for like cross-chain border transfer.
Yeah, I guess because effectively you're talking about, in this case, that application being, let me give you the interface for how do we talk, so which is like the ERC20 analogy in this case, where we know this what the standard is, how to represent this type of asset, but we're not talking about fundamental networking layer standardization. Maybe one quick open last question to any one of you. If you were to do a call for what's missing, at least on the developer tooling side, what are some things that would make working with cross-chain blockchains and just kind of actually do those types of applications a lot easier? Is there something obvious that comes to mind, something that you think is missing, or we just don't think somebody has paid enough attention to these types of toolings? What's out there that we can instruct developers to kind of open source or work on?
I mean, bridges are pigs. They create a terrible user experience and they're insecure. So just remove bridges, have blockchains talking to each other directly, and everything will be much better and simpler too.
Amen.
Me? Okay, so ZK Bridge actually is built on a zero proof, where our proof system actually need a lot of help. Like, we need a compiler for our proof system from high-level language to our arithmetic. We call it circuit, but it's different from Planck circuit or growth circuit. So actually, we do need the compiler people. Anyone here works on a compiler? Anyway, and secondly, since we are using proofs to generate to secure bridges, we need a very high performance computing code. So any CUDA people, ROCm people, Metal people here, we can also have contact here. Basically, we need, in general, we need to build a full stack of computing, basically. The compiler, execution, environment. Well, that's all about our future steps. It's kind of missing, because with this thing, we can further bring the cost of bridging down from maybe currently we are several cents of US dollar. Maybe in the future we can 0.1 cent of US dollar per transaction. Yeah, with this help.
Yeah, for me, top of mind, very recently looking at Bitcoin tooling, there is not much around compared to EVM ecosystem, and some of that's by design. It's simpler in nature, but even things like node access, all of that for developers is not very robust, at least from what I've seen. The other side is, I think developers have a lot of choice right now. There are a lot of chains to deploy on, a lot of messaging solutions, and committing to one is a very tall ask for a developer right now. A lot of people will maybe just default to going to whoever will give them the largest grant, not necessarily what chain is bringing the right value to their app, like whether that is performance or security. So at least what we want to build for developers is a way to build something that is future-proof or agnostic in a way where you can deploy, and even if there are new chains that you want access to, whether it's for liquidity or some other small component, you have access to that going forward as we add chain support. So it's not like you are deploying something that is going to be tied to this one siloed ecosystem for the future.
Awesome. Well, I want to thank all three of you for an amazing conversation, and really appreciate your time.
Thanks.
Thank you, Tom.
Thank you.